Hello guys, so today the topic will be inverse of a matrix. So we will see in this video we will see how to solve 3 cross 3 matrix by row operation. Okay, there are two methods of finding the inverse of a matrix. One will be adjoint method, which we will do in determinants, and one will be row operation method, which we will do in matrices. Okay, so we will be doing row operation method, row or column operation method. Our topic is how to find the inverse of a matrix. Now there are two methods to find the inverse of a matrix. The first one is by row operation method. Okay, this will be in matrices. The next one will be adjoint method in determinants. Okay, this will be done in another video. So here we will see inverse of a matrix by row operation method. Okay, so what are the things you require? Prerequisite. It means what are the things required to understand this topic. Okay, so let's see, that is properties of row and column operation. Okay, so these properties, if you don't know, these are very important. If you don't know, you will not be able to understand this. Okay, so you need to understand, you need to know the properties of row and column operation, then only you'll be able to solve the matrix or find the inverse of a matrix by row operation method. Okay, so the properties you better write down, and I will explain each property by using an example. So first is addition of one row or column to the other. Okay, so if you are doing column operation, you will be using these kind of operations where columns are involved, and if you are using row operation, then you will use this kind of operation where rows are involved. Okay, now they are saying row I times. Now the first is addition. We add two rows. Okay, so you can see this is the row where operation is applied, and with this row see another row has been added. Okay, so let's see an example on this. Example, if I have a matrix A, suppose I have 1 2 3 and 2. Okay, now suppose I want to make this element, I want to make it 3, as I'm saying. So what will you do? How can you make this element as 3? You will just add 2 here, right? But in row operation directly you cannot add 2. You have to take use of another row. So here what I will write, my target is this, it is in the first row. So I will put my row 1 under operation, and then I will say row 1 has to be added to row 2 to get 3. Clear? Just focus on this element, nothing else. Don't look at everything, just focus on one term at a time. Okay, so now when you add, what will you get? See, row 1 is under operation, but row 2 is not under operation, so row 2 as it is you can write 2 2, but row 1 will be row 1 plus row 2, so 1 plus 2 will be 3, and 3 plus 2 will be 5. This is how we will get. Clear? So if you are, suppose you have another one here, 1 3 2 2. Okay, now this is the same matrix. Okay, I want to bring up 4 here using column operation. So what will I do? C2 I will put under operation because C2 has that element which we are concerned with. So C2 plus C1. Okay, so which is, you can see C1 is not under operation, so I will keep C1 as it is. Okay, and C2 is 3 plus 1 is 4, and 2 plus 2 is 4. Okay, so I'm getting 4 here. Okay, now let's see the second one. Subtraction. Suppose I have 1, 3, 2, 2. Okay, I will be showing you row operations, all of them, because mostly we use row operation. Column you can use, see it by yourself. So this is my matrix, and I tell you I want 1 here. I want 1 here. So what will you think? You have to subtract 1. Okay, so there is a 1. Okay, I am saying it by myself because you need to use these. You need to learn how to use this. Okay, that's why I'm making it up. So because you want to make 1 here. Okay, so what will you do if I want to make 1 here? We will see later that we cannot decide what we want to bring here. Okay, just for now I'm saying that if I want to make 1, so what will I do? Row 2 I will put under operation because this element is in row 2. So row 2 minus row 1. So it's simple. You can see that this will become 1. So row 1 is not under operation, so you keep it as it is. This one 2 minus 1 will give me 1, and 2 minus 3 will give me minus 1. So this is how you will get 1 here. Okay, look at one element at a time. Clear? So this is how you will use row. Next operation is multiplication of row by a scalar. So what do we mean by this? Suppose I have a matrix 1, 3, 2, 2. Okay. Now here what I can do is I can multiply any row with a constant. Okay, suppose I want to make this 1. Okay, this multiplication, keep in mind, it can be done like this. I can multiply any row with some constant like this, or I can multiply by something like this. Okay, not necessarily 2 will be there, but you can see that this multiplication operation deals with multiplication as well as divide also. Okay, so you will not write a row I divided by 2. Instead you will write 1 by 2 multiplied by row I. Okay, so multiplication, you can multiply with a fraction, you can multiply with an integral number. Okay, so by saying that, if I want to make a 1 here, you can do by subtraction, no doubt. Okay, if I want to make 1 here, you can do subtraction, no doubt, but I want to show you this operation for now. So let's see this. So row 1 should go under operation because the element is in row 1, and if I want to make this one 1, so I will multiply by 1 by 3 into row 1. Clear? So what will be my A now? It will be row 2 remains as it is because it is not under operation. And this will be 1 by 3, and this element will be 1 by 3 into 1, right? So it will be this, and this one will be 1 by 3 into 3. So this will give me 1. Clear? So these are examples. Just to understand. Okay? You can write down only the operations. These examples you will know. If you start using, you will know. Okay, let's see the next operation. This operation is the main one which we will be using mostly. It involves addition, subtraction. Okay, here I have written plus, you can write minus also. Okay, here I have written multiplication of one row column by a scalar and adding or subtracting from another row or column. Okay, so in place of this there can be minus also. So suppose I have a matrix like this: 1, 3, 2, 2. Okay, now I want to make this one 0. Okay, how will I make it 0? Now see, there is a 1, right? So can I multiply 2 to this 1 and subtract from here? Yes. So see, this is my 2, minus 2 I multiplied with this one. So will it give 0? Yes. So I will get this. I will get 0 here in place of this by doing this. So what I will do, this is in row 2. So I will say row 2 should be under operation. So what will I do? With row 2, I will subtract 2 times of row 1. I'll multiply 2. That's what I have done here. I multiplied 2 here and subtracted from this row 2. That's what I have written here. Row 2 minus 2 times row 1. And you can see here in that row, multiplication of one row or column by a scalar. See, this row I multiplied with a scalar and adding or subtracting. Here I did subtraction, here I have written plus. Okay, so if you want to get 5, then you need to do plus here. So like that, you can write plus also. I have written minus. Okay, so this is what this point, this operation says, that you can multiply a constant to one row and subtract it from another. This is what it says. Okay, so this is another operation which is very important. This is very important. If you did not get, please rewind and see again what I did here as well as here. Okay, so let's go to next one. Next property, where k is a constant. Okay, this k can be constant. I am writing 2, it can be 3, 4, 5, whatever it is. Next one is interchanging rows and columns. Okay, interchanging rows and columns. Suppose you have a as 1, 0, 2, 3. Okay, you can do this. Row 1 interchanging with row 2. Clear? So this will become 2, 3 and 1, 0. This is how they interchange each other. Okay, so these are the 5 operations which you need to by heart to, in order to find the inverse of a matrix by row operation method. Okay, next thing we need to know is multiplicative inverse. So now what is multiplicative inverse? In smaller classes we have seen that if you are given a number 3, so teacher will ask you that what is the multiplicative inverse of 3. So you will say 1 by 3. Why? Because it will give us 1, the identity element, right? So here also, if you want to find the multiplicative inverse of a, then we need to multiply a by 1 by a. That is, we write like this: a multiplied by 1 by a, that will give you the identity element 1. Or in other words, we can write a, and this can be written as a to the power minus 1 equals to 1. I can write, okay. But the same thing can be written like this: from here a goes here, and then I can say this part is here, see, a into 1, this a goes here, it is here. Clear? So we can write like this for numbers. If suppose a is some constant, so I have shown you here also. Can I write this as 3 equals to 3 into 1, right? So this is what we have written here. Clear? Now you see, so similarly in matrices we use a equals to a into 1. Here this will be treated as identity matrix. Okay, in numbers we had 1. In matrices we will have identity matrix. You know what is an identity matrix? A matrix which looks like this. Okay, for 2 plus 2, for 3 plus 3, it looks like this: 1, 0, 0, 0, 1, 0, 0, 0, 1, right? It looks like this. So if for column operation you will use this method. Okay, and for row operation you will use this method. I'll show you how to use this. Okay, but know that when you are doing column operation to solve a problem, you will write a equals to a into I. When you are doing row operation, you will write a equals to I into a. Okay, And when you are using column operation, you will not use row operation in that. If you are using row operation, you will not use column operation in that. Okay, so here where I is the identity matrix and A is the given matrix. Okay, now to find the inverse in row operation of 3 cross 3 matrix, we need to proceed in the predetermined way and transform the given matrix to identity matrix. You have to proceed like this. See, first you need to make this one 1, then you need to go here, make this one 0, then you need to go to this one, make 0, then you have to go to the middle element here and make it 1. Okay, then you need to go to this. You can go down also. From down you have to move up, or you can go up. From up you can move down here. Okay, or you can have the other way. You can go down and go up, and then from here you can come to this. Okay, but here I have given this, so you go up and then from there come here and make this one 0, and then proceed to this, make it 1, then go up 0, then here make it 0. So this is how you will proceed. Okay, keep in mind how you will go. Okay, and I will be using this. Now let's solve a problem. Okay, do a correction here. You will have a minus sign here. It is minus 5. So first thing, I will make a partition. Okay, now let A equals to IA because I am using row operation. Okay, so what I will be writing, place of A 1 3 minus 2 minus 3 0 minus 5 2 5 0 is equals to, I will be written 1 0 0 0 1 0 0 0 1. This is it. Okay, now we need to proceed in a predetermined way, which I showed you before, so you remember that. So the first term has to be made 1, but here it is already 1, so I'm not worried about that. I'm worried about this one now. I need to make this one 0. Okay, so how will I make 0? If I add 3 here, it will become 0. Yeah, so focus on this element only, nothing else. If I add 3 here, it will become 0. So what will I do? Row 2 tends to row 2 plus, I will multiply 3 here and add here. So 3 times row 1. Okay, just look at the elements and corresponding rows you write on the operation. So now you can see only row 2 is under operation, so row 1 and row 3 you write as it is. 1 3 and minus 2 2 5 and 0, and row 2c minus 3 is coming from row 2 plus 3 times row 1 is 1, so you can see this becomes 0, so you can write 0 here. This one, row 2 is 0 plus 3 times row 1 is 3, so this is 9. Let's see 9 here, and this one, row 2 is minus 5 plus 3 times row 1. Row 1 is minus 2, so this is minus 11, so this is minus 11. Now this is equals to, you apply that same operation in this also. So 1 0 0 0 0 1 and A as it is. So here you see here you can see root is 0 plus 3 times row 1. Row 1 is 1, so this is 3 only. You will get 3. Next one is 1. Row 2 element is 1 plus 3 times 0. So this will give me 1. So this is your 1. Again in the third element, 0 plus 3 times row 1, that is 0. So this will give me 0. So this is 0. Okay. Now I need to make this one 0. How will I make 0? I will subtract 2. I will multiply 2 here and subtract here. Okay. So row 3 is under operation because the element is in row 3. So row 3 minus 2 times row 1. Okay. So the operation is in row 3. So row 1 and row 2 will not be affected. And row 3 will undergo operation. So row 3 has C here. It has 2 row 3 minus 2 times row 1 is 1. So that is 0. Row 3 is 5 minus 2 times 5 minus 2 times 3, right? So this 5 minus 6 is minus 1. Now the last term is 0 here, last element is 0, minus 2 times of row 1. Row 1 is minus 2, so this is 4. Okay, equals to, now you see the same operation will be applied on the right hand side. Now see, row 3 is 0 minus 2 times row 1 is 2, so this is minus 2. Okay, you can write your elements 1 0 0 3 1 0. The last row is in under operation, so you keep it for a while. Do the operation here. So this is 0. Row 3 is 0 minus 2 times row 1. This is also 0. That will give me 0. Now here row 3 is 1 minus 2 times row 1. Row 1 is 0. So this will give me 1. This is A. Clear? Now my problem is solved till here. Okay. Now you see the problem. Now this one I have to make it 1. How will I make it 1? So what will I do? Row 2 tends to 1 by 9 of row 2, can I say, to make it 1? Yes. So see what I will get. Row 1 is not under operation, so I write it as it is. Okay. Okay, now if you see here, this one multiplied by 1 by 9 will give me 0 only. This one multiplied by 1 by 9 will give me 1. But this one multiplied by 1 by 9. 1 by 9 into minus 11, if I do, I will get minus 11 by 9. Okay? So same thing I will do here. 1 0 0 minus 2 0 1. Look here, this is your row 2. So 1 by 9 into 3, that will give me 1 by 3. Okay, and then go to the second term, 1. 1 by 9 into 1 will give me 1 by 9, and 1 by 9 into 0 will give me 0. Okay, now once I get 1 here, I need to make this one 0 and this one 0. So let's make this one 0. How will I make 0? Row 1 I will put under operation, and row 1 minus 3 times row 2. Okay, 3 times row 2. So this implies row 2 will not be affected. I'll write it as it is. And row 1 will be, I'll be applying operation in row 1. So row 1, see, what is your row 1? Row 1 is 1 minus 3 times row 2, right? So what is your row 2? 0. So into 0. So that will give me 1 only. Yeah. And here, second one, 3. Row 1 is 3 minus 3 times row 2 is 1. This is here 0. Next one is row 1 is minus 2. Minus 2 minus 3 times row 2, right? So minus 3 times row 2 is how much? Minus 11 by 9. Okay, so this will be written as minus 2 plus 33 by 9. So this can be written as 11 by 3. So minus 2 plus 11 by 3. Take LCM 3 minus 6 plus 11, which will give you 5 by 3. Okay, it will give you 5 by 3. So here I will get 5 by 3. Clear? Now let's round this up. For the beginning, you move in this way. Okay. Once you become good in solving this, then you can see which operation can be done without hampering these rows, these elements, without hampering these elements. Okay. Then you can decide. Okay. Here I could have added this row 3 times of this, because I know that if I multiply 3 here, nothing will change in this one. So I could have done that to make this 0 first. Yes. Okay. The other way is also need to do, but understand this. Okay, so now here, okay, so now you can see row 1 is under operation. So row 1 is 1 minus 3 times, see here, 3 times of 1 by 3, right? Row 1 minus 3 times of row 2. So row 1 is 1 minus 3 into 1 by 3. That is what I have written. I will get 0. So this element will be 0. The next one will be, look at this and read from here. 0 minus 3 into 1 by 9. 0 minus 3 into 1 by 9. So 0 minus 3 into 1 by 9. So see what you will get, minus 1 by 3. Minus 1 by 3. Okay, next one. So looking at the operation, you see row 1 minus 3 row 2. So row 1 is 0 minus 3 times 0. It means 0 only. That is 1 by 3, 1 by 9, and this is 0, minus 2, 0 and 1. Okay. Now you can see I needed 0 here. So what will I do? Row 3 tends to row 3 plus row 2. Because I can just add and get 0, right? You don't need to multiply anything. So row 1 and row 2 are not affected. So I will write 1, 0, 5 by 3, 0, 1, minus 11 by 9, and this one is 0 plus row 3 plus row 2. So this is 0 plus 0 will give me 0, minus 1 plus 1 is 0, 4 plus minus 11 by 9. So 4 minus 11 by 9. Okay, so this is 36 minus 11 by 9, right? So this is 25 by 9. Okay, so you'll get 25 by 9 here. Let's remove this. Let's look at the right hand side. So row 1 you keep as it is, minus 1 by 3, 0, 1 by 3, 1 by 9, and 0, but row 3 has to be changed. So row 3 is row 3 plus row 2, so minus 2 plus 1 by 3, which is 3 LCM minus 6 plus 1, which will give me minus 5 by 3. So minus 5 by 3, you're getting now next you can see this row 3 plus row 2 will give me 1 by 9 only. Okay, row 3 is 0 plus 1 by 9. Okay, and again row 3 plus row 2, that is 1 plus 0 will give me 1. So it is there. So A is there. Now I need to move in this direction. I need to multiply so that I can make it 1. Okay, so row 3 tends to 9 by 25 of row 3. See, I need to make it 1. So if I have 25 by 9, then I will multiply by 9 by 25. Okay, so that's what I'm doing. So let's see what we can write here. 105 by 3, 0, 1 minus 11 by 9. Okay, now you multiply with 9 by 25. So here it's 0, 0. Here you multiply, you'll get 1. So the main change will come here. 0 minus 1 by 3, 0, 1 by 3, 1 by 9, and this is 0. Here you multiply. So 9 by 25 into row 3, that is minus 5 by 3, right? So this is 3, this is 5, so this will give us, so this will give us minus 3 by 5. The next one, row 3, see, 9 by 25 into row 3 is 1 by 9, 1 by 9, so that should give you 1 by 25. So this is 1 by 25. Clear? The last one is 1, so you can directly write 9 by 25 here. Okay, 9 by 25. So this is what you are getting. Now let's see. We need to make this part 0 and this one 0. So Row 2 I will put under operation. I'll put row 2 under operation. So row 2 tends to row 2 plus 11 by 9 of row 3. Can you see that I will multiply 11 by 9 here and then add here, it will become 0. And see, by moving this away, you don't have to think about keeping these as it is. Okay, if you move like this will never change if you are applying the operations in that way. So let's see what you will get. Row 1 as it is, row 3 as it is. Okay, so this one, see, row 2 is 0 plus 11 by 9 of row 3 is again 0, so this will give me 0. Okay, so here row 2 is 1 plus 11 by 9, 11 by 9 of row 3 is 0, so it will give me 1 only. Okay, here you can see minus 11 by 9 row 2 plus 11 by 9 into row 3 is 1, so this will become 0. This will make it 0. Understand? So let's see now, the main change happens here. This will give us the real matrix. So we are focused on this. So row 1 remains as it is, 0 minus 1 by 3, 0, and row 3 remains as it is, minus 3 by 5, 1 by 25, 9 by 25. Okay, so row plus row 2 is 1 by 3 plus 11 by 9 of row 3. Now row 3 is minus 3 by 5. Okay, so now you can see this and this can be cancelled 3 times. Okay, so you will get what you will get, 1 by 3 from here, 1 by 3 minus 11 by 15. So what is your LCM? Your LCM is 15. Right, there's 5 minus, and then this is 11, so this is minus 6 by 15, that is 3 to the 6, 3 5 by 15, so this is minus 2 by 5, right? So here I will put minus 2 by 5. Clear? Okay, similarly now for the next element, row 2 is 1 by 9 plus 11 by 9 of row 3, that means 1 by 25. Here you can see 1 by 9 plus 11 by 9 of 1 by 25. So you can see that I'll write here. So 1 by 9 plus 11 by 9 into 25. Okay. So LCM you write down 9 into 25. I'll multiply later. So I will write here 9 LCM. So I will write 25 plus 11. So this is 36 by 9 into 25. Why did I do? Because I don't want to multiply them and then again cancel it. Multiply and then again cancel, it's same as not multiplying, and later you can see you can cancel. So 9 4 is 36, so you will be getting 4 by 25. Yeah. Now let's see the last element. Last element row 2 is 0 plus 11 by 9 of row 3, that means 9 by 25. So 9 cancels, I will have 11 by 25. Clear? Now only problem left is this element. Okay. Now how will I make it 0? Same idea. Row 1 put on the operation. Row 1, here I did plus because it was minus already here. Okay, so here there is a plus, I will do minus. I will multiply. How to make this 0? I multiply 5 by 3 to row 3 and subtract from here. Clear? To make it 1 I need to multiply with reciprocal, but to make it 0 I will subtract. Okay, so let's see. This is my last step. This is one. Okay, don't. The row 2 and row 3 can be written as it is. 0 0 1. Row 1 is under operation. Okay, so row 1, 1 minus 5 by 3 of this. 1 minus 5 by 3 of 0. So 1 only. Okay, next is 0 minus 5 by 3 of 0. Okay, once you are done practicing, you will see that you don't have to do directly. You will write this, you write directly 1. Oh, sorry, directly you will write 0 here. Let's see. I'm showing you here, so let's find out. So this is 5 by 3 minus 5 by 3 into row 3 is 1. So this will give us 0. Clear? Okay, now what we have to do is here minus 2 by 5, 4 by 25, 11 by 25, minus 3 by 5, 1 by 25, 9 by 25. Okay, and then row 1. Row 1 is 0, here 0, minus 5 by 3, 3 of row 3 minus 3 by 5. This and this cancel, this and this cancel. Don't say 0 remaining. There is 1 remaining. So minus minus plus, plus 1 is remaining here. Clear? Next, row 1. Row 1 is minus 1 by 3 minus 5 by 3 of root 3. Root 3 is 1 by 25. So this is 5 times. Okay, and this is minus 1 by 3 minus 1 by 15. Okay, if we take LCM, that is 15. So this is 3 into 5 also you can write. So this is minus 5. Okay, and this is minus 1. So this is minus 6 by 15. That should give you minus 2 by 5. Clear? Now the last element is, look here, row 1 is 0 minus 5 by 3 of row 3, that is 9 by 25. This is 5 times, this is 3 times, so this is minus 3 by 5. Okay, now you can see here what happened, that now you can see that I can write this is I equals to A inverse A, right? So I can call this an inverse, and you will see if you multiply this matrix with this one A, you will get this one. Okay, So I can say my A inverse is, below that you can write therefore A inverse is 1 minus 2 by 5 minus 3 by 5 minus 2 by 5, 4 by 25, 11 by 25, minus 3 by 5, 1 by 25, 9 by 25. Okay, if there is some mistake, you please change it. Previous slide it was correct. Here, if you find anything mistake, you change it from there. Okay, so this is how you will solve a 3 cross 3 matrix. Okay, so this is it for row operation method. Okay, so I'll see you in next video. Thank you for watching.